Okay, so for part 4 here, we're on the back of this. Find the point of intersection between each circle and the line with the equations given. So what we have here, this is the equation for a circle. This is a linear equation, y equals mx plus b. What we want is the point of intersection. If you were to graph this, you would have a circle. Now, then you would have a line, and when you draw the line, there are some possibilities. I could draw the line where it doesn't intersect the circle at all, and so the answer is no solution. I could draw the line where it touches the circle at one place, and so there's one solution, there's one point of intersection. Or I could draw the line where it intersects the circle in two places. And so there are two answers. So we're going to see what happens with this. We're looking at this as what we call a system of equations. System of equations. Two equations with two variables. The first equation has x and y, and so does the second equation. So what we're assuming, though, is that this x value, whatever it is the same as this one. And this y value is the same as this one. So what I'm going to use here, there are different ways to solve this. I'll say here's equation 1, here's equation 2. I'm going to take the second equation, which is already set up as y equals negative 2x minus 2. If that's what y is equal to in the bottom equation, that is also what y is equal to in the top equation. I'm going to take this and substitute for y in the top equation, which means I'm going to rewrite equation 1. X minus 2 parentheses squared plus. The y value, I'm going to replace it, I'm going to substitute with negative 2x minus 2 and then plus 3 squared equals 18. Now I can simplify a little more. This is negative 2x. I can combine like terms. Negative 2 plus 3 is 1. Plus 1 squared equals 18. So now what I want to do, since this equation only has x's, this is something that we can solve, but what I need to do first is to multiply these out. I need to square them. I'm going to double distribute. So x plus 2 squared is x minus 2 times x minus 2. Negative 2x plus 1 squared, I'm going to double distribute negative 2x plus 1 times negative 2x plus 1. So what I need to do here is, I'm going to skip some steps, but if you work this out, you'll get x squared minus 4x plus 4. And then if I square this out, if I double distribute, I'll get 4x squared minus 4x plus 1 equals 18. Well, combine like terms, 1x squared and 4x squared. So that's 5x squared. Negative 4x and negative 4x is negative 8x minus 8x. And then positive 4 plus 1 is plus 5 equals 18. Now to solve this, this is a quadratic. This is not a perfect square trinomial. I'm going to move everything to one side, and we get 5x squared minus 8x minus 13 is equal to 0. Now there's a couple ways I can do this. You can use quadratic formula, which is that long equation with the square root. I'm actually going to factor this. And so I'm going to use a process called factoring by grouping. I'm going to come up here. So 5x squared minus 8x minus 13 is 0. So to factor this, I do 5 times negative 13, which is negative 65. And then I'm thinking, what multiplies to negative 65 and adds up to negative 8? Okay, I'm assuming that you've done this before, that you know how to factor, because I am going through this quickly. So what multiplies to negative 65? Well, there's 1 in 65, and there's 5 in 13. There are not many factors that multiply to 65. Now, which of these can add up to negative 8? Well, plus 5 and negative 13. A positive times a negative gives me negative 65, and if I add those, I get negative 8. So what I'm going to do now is rewrite this where my middle term, negative 8x, is this, 5x squared. This is plus 5x minus 13x. That's still negative 8x minus 13 is equal to 0. Now, I'm going to factor by grouping. Factor by grouping. I'm going to group the first pair of terms together and factor out the greatest common factor, which is both of these can be factored by 5x. So I pull out a 5x, which leaves us with x plus 1. 5x times x is 5x squared. 5x times 1 is 5x. In the second pair of terms, both of these can be divided by negative 13. So I'm going to factor that out, which leaves us, if I divide by negative 13, we get 1x plus 1. Now both of these terms have this factor, x plus 1, so I'm going to factor that out and get 5x minus 13 left over. And so what I do, I set each factor equal to 0, and I solve it. I would go minus 1, so x equals negative 1, and then plus 13 plus 13. 5x is 13, divide by 5. X equals 13 over 5, or 2.6. Okay, now those are the x's, but I haven't found the y values yet. So to find the y values, I have to take these two numbers, and I need to go back to my system. I'm going to substitute into y equals negative 2x minus 2. So y equals negative 2x minus 2. What was my x value? Well, here it was negative 1. That's 2 minus 2, which is 0. So one answer for y is 0. And then here, if I do y equals negative 2 times, I'll say 13/5 minus 2, that's y equals negative 26 over 5. This would be minus 10 over 5 equals negative 36 over 5. Okay, there's a lot of work here. So what we get is two answers. Negative 1, 0. That's 1 point of intersection. And 13 over 5, negative 36 over 5. That's the other point of intersection, x, y. Now, is that accurate? Well, you could plug these back in and see if it makes, if I put negative 1 in, that would be minus 3 squared, that's 9. 0 plus 3 is 3 squared is 9. 9 plus 9 is 18. Negative 2 times negative 1 is 2. Minus 2 is 0. So this one checks. This one will also check. Just to show you if I graph what the picture would look like. Now here's my circle. Okay, it doesn't connect all the way, but notice that the line is intersecting in two places. So here's negative 1, 0, and here's 13 over 5, comma negative 36 over 5. So that's how I solve that. Last problem here, 20. Write an equation of a circle that contains r, 1 comma 2, s, negative 3 comma 4, and t, negative 5 comma 0. Now this one, there are a couple ways to do this, and I'm going to show you that in this situation there's kind of a shortcut. If I connect these 3 points, excuse me, the center of the circle is somewhere over here, because these are endpoints on the circle. I'm looking for the point that's the same distance from r and s and t. But one thing that's going to happen if I look at slope, this kind of looks like a right angle, angle S. And if I count slope, that's 4 over 2, which is 2 over 1. And if I count this slope, it's down 2 and right 4, which is negative 1/2. Now what we get is one slope is 2 over 1, one slope is negative 1 over 2. Those are opposite reciprocals. And what that means is that these are perpendicular. They make a right angle. So actually this is a right angle. I can put that in there. Now one of the rules on a circle, okay, again you have to kind of imagine, here's your circle, that if you have a right angle inscribed in the circle, that this third side here, if I make this a triangle, that is going to be our diameter. That's going to be the diameter. So if I could find the center of this, I would have my center of the circle. If I could find the midpoint of TR, because half of a diameter is a radius. So if I take TR, I'm going to do the midpoint formula, which is where I add my x's. So I'll take -5 plus 1 over 2, comma, and then I add my y's, 0 plus 2 over 2, and we work that out. That's -4 over 2, comma, 2 over 2, which is -2, comma, 1. That is your center. So if I say here's -2, comma, 1, that is the center of the circle. Now what's kind of cool here is we could actually draw this now. If I take the center, and okay, I'm going to try to do this. This is not going to be great. Come around. Oh boy, not perfect. Not perfect at all. There we go. Oops. Okay, but you can kind of see it. I know it's not great. But if I could draw it perfectly, you can see that it's not bad. Okay, I know I'm off a little bit, but you can see that each of these, it goes through R and T and S if I've done it correctly. There's the center. Well, that means that I can say x plus 2 squared plus y minus 1 squared equals r squared. So we're missing the radius squared. Well, all we need is an xy value. We actually have 3 of these. You can use t or s or r. I'm going to use r because it's positive, 1 and 2. So I'm going to use 1 comma 2, where x is 1, y is 2. So I put the 1 in for x. I put the 2 in for y. 3 squared plus 1 squared, that's 9 plus 1, which is 10. Now for the equation, I'm actually done. If you want the radius, you would take the square root of 10, which is close to 3, a little bit more than 3. But the equation, x plus 2 squared plus y minus 1 squared equals 10. R squared is equal to 10. That is the equation of the circle. Okay, so again, there's a lot of work here. The relationship that you need to know that we may not have talked about yet is that when you have an angle inscribed in a circle that's a 90, it means it's going to intersect or intercept a diameter. So I know that TR is the diameter. And that's why if I take the midpoint, that has to be the center of the circle. So I did the midpoint of TR to get the center, and then I used the equation to find R squared. Now there is another way to do this. I'm not going to do it, but just to show you, what happens if that's not a right angle, then this is not a diameter. But one thing that you can do is you can draw the perpendicular bisectors of both segments, and where they meet would be the center. So if you could find the equation of that perpendicular bisector of SR and the perpendicular bisector of ST, and then find out where they're equal to each other, which would be like another system of equations, but they'd both be linear, it'd be a little simpler, that would also give you the center. So there's some cool stuff that we're doing here, but you see it's a lot of work, a lot of different connections we're making. And that's the end of part 4.